The second example for the double integration method. So for example, we have this cantilever beam. So it is loaded with a varying load which is 15 kilonewtons per meter for a span of 6 meters. So the modulus of elasticity is given as 200 megapascals. Moment of inertia is 220 times 10 raised to 6 millimeters to the fourth. So required, what will be the rotation at A and what will be the value of the maximum deflection. So again, first we are to set our cutting section. So we are to cut, for example, this beam at a distance x from the free end, which is A. So we don't know the magnitude of the varying load at this point that corresponds with the horizontal distance x. Let's say this is y. So we cut this section, then expose. Okay, so again, we don't know the magnitude of this y at the distance x. So we can have it by ratio and proportion of similar triangles. So let's say this is, the triangle is 15 kilonewtons per meter is to 6 meters. Then we have y is to x. So again, from this cut section, we will be having a counterclockwise moment. So by ratio and proportion, we have y is to x, that is y is to x. We'll be having equal to, this is 15 is to 6 meters. So we'll be having y is equal to 15 over 6 is equal to 5 over 2 of x. So we'll be having a magnitude. Okay, let us determine the equivalent weight of this distance x. And what will be the equivalent weight? So take note, if you are to compute for the equivalent weight of a varying load, that is basically equal to its area. So area of a triangle. That is 1/2 of the base x and the height is y. So we have the equivalent weight, so equal to 1/2 of x. What is the value of y? So we have the value of y as 5 over 2 of x. So the equivalent weight is equal to, that is 1/2 of x times 5 over 2 of x. We'll be having a value of 5 over 4 x squared. Now we do summation moment about this cut section. So by summation of moment equal to 0, clockwise moments to be positive. So this is equal to 5 over 4 of x squared. This is at a distance of 1/3 of x. Okay? So 1/3 dun from the cut section. So counterclockwise, so that means it is negative 5 over 4 of x squared. What is the equivalent lever arm? That is 1 over 3 of x. Minus this moment, because it is a cut and exposed section, equal to 0. So we'll be having a moment equal to, this is negative 5 over 12 of x cubed. So ganun lang naman, we have only one term on each side. So that will be our moment equation, negative 5 over 12 of x cubed. So if we are now to proceed to integration, so we have the equivalent of EIY double prime is equal to the moment. So this is EIY double prime is equal to, okay, we have negative 5 over 12 of x cubed. Okay, that is our moment equation. So integrating both sides of the equation, this is now equal to EIY prime is equal to, this is negative 5 over 12 of x to the fourth divided by 4. So plus the first arbitrary constant. So this is, we have EIY prime is equal to, this is negative 5 over 48 of x to the fourth plus c1. So again, this is our slope, the slope equation. Alright, so we again integrate the slope equation. So this is the integral of EIY prime is equal to the integral of negative 5 over 48 of x to the fourth plus c sub 1. So this is now EIY equal to, okay, we have negative 5 over 48 multiplied by x to the fifth divided by 5, okay, plus c sub 1x plus, okay, the second arbitrary constant. So we have now the deflection equation EIY is now equal to negative 1 over 48 of x to the fifth plus c1x plus c sub 2. So this will be our deflection equation. Alright, so we have now the deflection equation and the slope equation. So to determine the requirements, all we have to do is first, compute muna natin yung mga arbitrary constants. Okay, so again, most of the time, kinukuha natin yung mga arbitrary constants by assuming a value of x, usually sa supports. So again, this is our y-axis and horizontal will be the x-axis. Then we have to draw the exaggerated deflected form of the beam. So what is the equivalent deflected form? So usually, obviously, magkakaroon tayo ng maximum deflection dito sa free end. So the maximum deflection will be occurring here at point A. So, okay, if we are to draw, but before that, so as you can see, we have only one support, which is a fixed support. So let's say at B, wherein the value of x is equal to 6. Okay, yung distances natin. So assume the left side to be the origin. This is 0, 0. Coordinate of B will be 6, 0. So we have at B is equal to 6. Okay, obviously since that is a support, we have a 0 deflection. Okay, so the deflection should be equal to 0. So if we are to observe the deflection equation, so this is EIY is equal to negative 1 over 48 of x to the fifth plus c1x plus the c sub 2. So we have this is EI0 equal to negative 1 over 48 of 6 raised to 5 plus we have c1 times 6 plus c sub 2. So this will be 0. Ikunin natin, so what is 6 raised to 5 divided by 48, that is 162 transpose. We'll be having our first equation. This will be 6 times c1, 6 times c sub 1 plus the c sub 2 is equal to 6 raised to 5 divided by 48 is negative 162, then transpose, that will be positive 162. So this will be our equation 1. So for if we are to observe here at point B, if we are to draw a tangent line to point B, so obviously as you can see this is horizontal. So if that is a horizontal tangent line, what is the slope of a horizontal tangent line from your analytic geometry? Y prime is equal to 0. So again, this is at B, wherein the value of x is equal to 6. We have y prime is equal to 0 since the tangent line at point B is horizontal. Okay? So balikan natin yung slope equation. Ito yan. And for the slope equation, this is EI y prime is equal to negative 5 over 48 of x raised to 4 plus the c sub 1. So this is, we have EIY prime, that's the value of y prime at x equal to 6, that is 0, equal to negative 5 over 48 times 6 raised to 4 plus c sub 1. So first thing to solve is the first arbitrary constant, c sub 1. So that will be negative 135, then transpose, so which means this is positive 135. Alright? So since we have now the first arbitrary constant, we can now compute for the C sub 2. And from this equation, we have this is 6 times 135, okay, plus C sub 2 is equal to 160, or 162. So let's compute for the value of the second arbitrary constant. 162 minus. That will be equal to negative, okay, negative 648. Okay, that will be the value of the arbitrary constants, C1 and C2. So if we are to summarize what is our slope equation, okay, the slope equation will be equal to EI y prime is equal to negative 5 over 48 of x raised to 4, okay, plus C1, and C1 is equal to 135. That is our slope equation. Then for the deflection equation, that's equal to EIY is equal to, this is negative 1 over 48 of x raised to 5 plus C1, which is 135 of x, 135x minus C sub 2, 648. So this is our deflection equation and slope equation and deflection equation. So let us solve the required rotation at A and the maximum deflection. So obviously, if you have a fixed support, and obviously if you have y prime is equal to 0, which means the rotation at B is basically equal to 0, since that is a fixed support. Okay? So ang kukunin natin dito, we have to compute for the rotation at A. Let's say this is theta sub A. So computing for the rotation at A, that is obviously at x is equal to x is equal to 0. So we have the slope equation. This is we have EI y prime is equal to negative 5 over 48 of x raised to 4 plus 135. So we'll be having this is EIY prime is equal to negative 5 over 48, obviously this is 0 to the 4th plus 135. So which means we'll be having the value of y prime equal to 135 divided by EI. So last time is the basic, that will be the unit kapag slope equation or second integration. That is in yung kilonewton ay meter squared. I say if we are to compute for the actual value, this is now y prime is equal to 135. This is multiplied by 1000 raised to 3. 1000 per kilonewton, then 1000 squared per meter squared. Para maging newton, mm squared. This is divided by, what is our E? The given kanina, we have 200,000 megapascals. And megapascal is the same as newtons per square mm. Then moment of inertia, given din siya kanina as 220 times 10 raised to 6 millimeters raised to 4. So if you have to do unit analysis, again, that will be unitless, cancelling newtons. And then to the 4th, mm squared, so this is mm squared, then cancel again. Are we have to compute? Okay, this is equal to 3.068 times 10 raised to negative 3 radian. And that will be the unit of the rotation at A in terms of the radian. So kung gusto natin degrees, this is multiplied by 180 degrees divided by pi. So this is now y prime, or let's say the rotation at A is now equal to, in terms of degrees, so times 180 divided by pi. So we have 0. And this is 0.176 degree. Okay, the rotation at A. As you can see, bakit positive yung rotation at A this time? If you are to observe, this is the horizontal position of the beam initially without the load. Upon the application of the load, it will obviously deflected downward. So this is the rotation of the beam. As you can see, this is counterclockwise. So which means we have a positive angle of rotation. And lastly, obviously our y max will be at A. This is the maximum deflection of the beam. Obviously kapag cantilever, the free end will be the maximum deflection. So let us compute. For the maximum deflection, what is our deflection equation? This is EIY, so equal to negative 1 over 48 of x raised to 5 plus 135 of x minus 648. So saan matatagpuan yung maximum deflection? That is at A, wherein the value of x is equal to 0. At x is equal to 0. So this is EIY is equal to negative 1 over 48 of 0 raised to 5 plus 135 times 0 minus 648. So this is 0, 0. We have EIY is equal to equal to 640 or negative 648. And the unit kapag deflection on this side, this is kilonewton meter cube. So from the slope, meter squared, on the deflection, meter cube. Since you integrate, okay, for the second time. So this is now y. The value of y is equal to negative 648 divided by EI. Kilonewton meter cube. So let's say this is now y is equal to negative 648 multiplied by 1,000 raised to 4, that is 1,000 for the kilonewton, 1,000 cube for the meter cube, para maging newton, millimeter cube. This is divided by E, the modulus of elasticity, we have 200,000 megapascals, newtons per mm squared. Moment of inertia given as 220 times 10 raised to 6 mm to the 4th. So again, if you are to do unit analysis, Newton, mm squared, mm, so this is squared cube. So we have a remaining unit on the numerator as millimeter. So this will be the y, or the y max, the maximum deflection. Is equal to negative 14.727 millimeters. So 15 mm, or that is approximately 1.5 centimeters. So is that unacceptable? If you are to construct a cantilever beam, is that acceptable kapag nakikita mo na may deflection? So you are to check that a structure can carry load, but it doesn't mean na pwede niya mabuhat yung structure, pero possible naman na nagsasag siya or nagde-deflection. So you should consider the beam can carry that load at the same time you have a very small deflection or no deflection at all. Okay, so this is our example.